should you get the COVID vaccine? It's a question that we're all asking each other and ourselves. And this we're going to break down will be a summary of the literature of the Pfizer COVID vaccine, what questions we should be asking ourselves to determine if we should get it, and a risk assessment of getting it versus not. And so to frame this conversation before we dive into the literature is the question of subjective risk. Is it more risky to get COVID-19 based on your individual health, demographic, and location, or more risky to get the vaccine? Then it's a question of systemic risk. Do you care about contributing towards herd immunity? Assuming this isn't seasonal and the vaccine confers long-term immunity across various strains. We don't know that exact answer yet, but this is a multifaceted considerations and variables of idiosyncratic personal risk versus and in conjunction with systemic risk. Okay? Important to note. Everybody's going to have their own individual answer depending on these variables. For example, is it more or less risky for you to get the vaccine? That answer will be different for someone living in New Jersey, having with 10,000 cases a day, versus someone living in Melbourne, Australia, right now with 0 cases for many weeks. And so that's a question of location. But it's also an important note, long-term side effects. Do you care about the long-term potential side effects? The things like ground glass ossification, chronic organ damage, heart damage, impact on kidney function, persistent symptoms like loss of taste and smell for months on end, fatigue. There are numerous studies, numerous accounts that talk about and discuss and analyze the long-term effects. So is that worth it to you? Is that a risk you're worth taking? Or is it not? This is a very individual question based on those other personal factors. And so it is important to note that your assessment of risk is not my assessment of risk. And it appears unfair for us to judge each other very harshly based if you are critically thinking about your own individual risk. Perhaps you can afford to wait because your state has 0 cases and you can use that time to gather more information. See more studies, see more of the effects. Or you're in a higher priority group, you're in a location with a lot of cases, and you don't want to risk the long-term side effects. Those are questions we all need to ask ourselves. Now, before we get into the evidence, it's important to note, Tulsi Gabbard brought out this great point. She was an ex-presidential candidate for the United States of America that I didn't think about. And I don't think many people are talking about yet. As of right now, this video being recorded on the 25th of January, 2021, which is when all this evidence is present, there is no evidence to show just because you have the vaccine doesn't mean you can't carry a viral load of the virus and transmit it. Just because you have the vaccine doesn't mean you're unable to transmit it to other people. And this is a very important consideration when you think, oh, I have the vaccine, I'm good. I can see everybody. I can go behave as normal amongst everybody. I can go kiss and hug my grandmother who hasn't had the vaccine. Well, maybe this isn't smart as of right now, because it doesn't appear that we know the answer. But based on what we do know, it's probably safe to assume that you can still transmit the virus, considering it can be stored and housed in the nasal passage, the mouth, certain orifices that have mucous membranes on them. So that's another consideration. If and when you do get it, and how you behave with other people who don't have it. Now, what about the risks? The risks of the vaccine. How safe is it? What are the side effects? Now, it's expected that there's always going to be a subset of the population who will have allergic adverse reactions, just like some people have allergic reactions to over-the-counter medication. This is not a zero-risk game. It's about managing and mitigating risk. And so we're going to see a lot of headlines that fearmonger about the adverse reactions to a vaccine or a medication or a supplement. We have to understand relative risk, and that there is no zero-risk game that human beings play. And that we all take a risk every time we go to a pharmacist or a doctor and we take a medication or a supplement. And so maybe let's apply the same critical thinking that we do there. What is this vaccine? So there are a few different types of vaccines. I'm going to talk about the Pfizer vaccine. That is where I've seen all of the research thus far. However, note, your vaccine that you're considering getting may not be Pfizer. So you cannot apply the same evidence that I'm about to purport here to yours. All of them have different levels of efficacy. The Pfizer vaccine, known by a couple names, Tosinumerin, Comirnaty, I'm saying those a bit off, my apologies. It's administered as 2 doses separated by 21 days. Now, this is United States evidence, okay? So it may be slightly different depending on your region. It is an mRNA vaccine. Now, this technology in humans is relatively new, but has promising efficacy. It's been used quite a bit more in animals, which is where we're leaning on a lot of this technological confidence in mRNA. The vaccine uses, so mRNA stands for messenger RNA, but what is mRNA? So mRNA becomes activated from its DNA form. DNA, number one, is the instruction manual of how to run the cell in a very layman's term. So the instruction manual. Now, the instruction manual, DNA, produces mRNA through a process called transcription. This RNA gets translated into protein. When the gene becomes activated, DNA in a gene is copied into the mRNA by certain enzymes inside the cell, the nucleus. Okay? So that's what mRNA is. The vaccine uses mRNA to trigger the body's immune system to produce antibodies against the virus. And this is generally a faster process than traditional vaccines. So to phrase it another way, mRNA vaccines make the instructions for the virus's spike protein. You know, you see those images online of the red virus with all the spikes on top? The spike protein is actually how the virus enters the cell, how it enters the host via ACE2 receptors. Side note, females actually have more ACE2 receptors than males, which explains why females are less susceptible to the virus. ACE2 receptors is where the actual virus injects its genetic material into the cytosol of the cell, and that's where it can replicate. And in COVID patients, ACE2 function is terrible. It's impaired. And so we've noticed that women actually express twice the number of ACE2 receptors as men, and so it sort of acts as like a backup population of receptors to carry out their normal function. And so their body's a bit more robust, and their immune system is a bit more robust against this heightened immune system response due to the number of ACE2 receptors that they have, and also a couple of different reasons like estrogen levels being different and other receptors that are different too. But it's just one little side note factor. Now, when we talk about the difference between like an mRNA vaccine and a traditional vaccine, it's important because most people have gotten traditional antiviral vaccines, and they're created by growing attenuated or weakened copies of a virus inside living cells from chicken eggs or mammalian cell lines. So the attenuated virus, or a portion of that, is injected into the humans to promote immunity. So you get a live portion of the virus. Now, this mRNA vaccine contains the genetic material to encode a single viral protein. So when the body receives the injected mRNA, like the instructions, it induces an antibody production against that protein. It's a bit more of a specific targeted response. And so the target viral protein facilitates movement of the virus across the cell membrane. And because mRNA degrades easily, it needs to be encapsulated in these special nanoparticles that have fat around them so it can be absorbed into the cell. So to summarize, mRNA injected into you, taken up by specific immune cells. Immune cells follow the instructions of that mRNA. The mRNA is the map. They follow the instructions on the map, and they act as they would if they were to become infected with the actual live virus. So the immune system mounts a response against it, and this is where the magic happens. This is where you make antibodies, T cells, B cells. You create immunitory memory. And so our immune system creates a memory of the virus. So when it sees it again, it has the codes, the instructions of how to deal with it and fight it. So that's an mRNA virus in summary. Okay? It's not going to be a perfect scientific PhD explanation, but hopefully that gives the basics. Safety and side effects of the Pfizer vaccine. So this was from a summary from the CDC in January 6, but as of December 23, 2020, we've had nearly 2 million doses, 2 million, if you would believe, nearly, of the Pfizer vaccine has actually already been administered in the US, just the US. And then actually Israel and countries surrounding it actually have a 1/10 of their population already as of the end of December who have got their citizens having the vaccine too. So this is really being rolled out faster than I think a lot of people appear to think. Now, out of those nearly 2 million in this study, they found 0.2% had adverse events after the vaccine. So 0.2% out of 1.9 million is a bit over 4,000 people. There's going to be people. There is absolutely always going to be people who respond. If you have a large enough sample size, there is going to be at some point people who have adverse responses. So what were these adverse responses? So 0.2%, that is a number one. What are you going to do with that number? Is that number within the threshold of reasonable risk for you? Because actually, that is quite good if you look at the average vaccine efficacy. In fact, some may say it's very good. But that's just looking at statistically from other vaccines. Now, among these, we had 175 who had anaphylaxis. Anaphylaxis is not just a closing up of the throat and a respiratory, oh, I can't breathe. It's just an allergic reaction to the vaccine. You can get vomiting, shortness of breath, nausea, skin rash. This usually happens very quickly, within the first minutes to 90 minutes, or 150 minutes actually is what they noticed. Okay, so if you've cleared that a couple of hour range and you get this vaccine, you've likely escaped or evaded many of the symptoms or the more aggressive adverse symptoms. But at the same time, don't nocebo yourself into getting the vaccine and then being like, oh, I got 2 hours, 3 hours. I wonder if I'm going to get sick. I wonder if I'm going to get like hives or skin, because the brain is powerful. Placebo, nocebo is very real. And there are going to be many people who are going to say they got symptoms, but we're going to misappropriate their symptoms to nocebo instead of actually a adverse response from the vaccine. Basically, if you didn't realize or got what nocebo meant, nocebo is the opposite placebo. Placebo meaning your brain triggers a beneficial effect from a dosage or stimulus of something. I give you a sugar pill, there's nothing in it. I tell you it's going to it's going to improve your energy, and your energy gets better 10 minutes later. I give you a nocebo, meaning I give you this pill, it's going to make you feel nauseous. There's nothing in the pill. It makes you feel nauseous. Nocebo. So, something to consider when we talk about symptoms. There's gray area in this stuff. So let's talk about it, because the headlines you read won't really. So that's one study, and that 0.2%, people can look at that and see whether that's worth it for them for this Pfizer vaccine. Number two, in December 10, 2020, a study, the safety and efficacy of the Pfizer mRNA vaccine. Clinical trial, 43,000 people. They noticed an efficacy rate of 95% in preventing the disease. Most common reactions. Okay, this is now beyond anaphylaxis because people want to know what else is there. Fatigue, headache, muscle pains, chills, joint pain, fever, and injection site reactions. So you might actually get some like tingling, weird feeling around the actual injection site, which is actually quite common in vaccines and probably very easy to nocebo yourself into doing. Now, this was a multinational study, placebo-controlled, observer-blinded. So there was a group that actually thought, well, they didn't know if they got the vaccine or not, okay? And the observer blinded. So the researcher actually didn't know who they were giving it to. So the researcher couldn't actually bias their response, or rather the observer. Randomly assigned 16 years and older. They received 2 doses, 21 days apart, 30 micrograms per dose. Important to note, your country and state, you may receive a different dosage, less or more, because I believe I've read up to 90 milligram dosages or microgram dosages. And so that's important. The dosage amount could change the effects. So out of this 43,000, there were actually 8 cases of COVID-19 with onset at least 7 days after the second dose. So after 7 days, 8 people still got COVID. Now, did they get COVID because they actually got it from another person? Or was it from the mRNA vaccine? Then they got a positive result. I can't tell. That's a very nuanced detail of the study, but something to be aware of. 162 people among those assigned to placebo actually got COVID-19 too. So after 7 days. So did they go out and then get it from somebody? Maybe. May have been some other variable as well. But Pfizer vaccine was 95% effective in preventing COVID-19. Their confidence interval was, the range of efficacy was between 90.3 to 97.6. Important to note, there's always a range, a confidence interval where we are 95% sure that the results sit within this range. They call it a credible interval, so I may be misinterpreting that as a confidence interval, but just to give you an idea of the range. Similar vaccine efficacy sits between 90 to 100%. So this Pfizer vaccine, sits between the average, if not a little bit better. And that was observed across subgroups defined by age, sex, race, ethnicity, BMI, and coexisting conditions. So the safety profile based on these 2 studies, or this study in particular, was characterized by short, mild to moderate pain at the injection site, fatigue, and headache. Serious events or serious adverse events were low in the vaccine and placebo groups. And these findings presented in this report suggest the Pfizer vaccine has an excellent safety profile and is safe for most people. Most people, and excellent being defined as 95% plus. For people 16 years and over, who got the 2 doses separated by 3 weeks, over a median of 2 months, where they observed the effects and still observed the patients and participants in the study. That's the evidence right now as of the 25th of January, 2021. There's going to be more research out there that I'm not covering. This is not a full, exhaustive, comprehensive analysis of every single research study. This is not a meta-analysis, okay? Watch out for those. Those are going to be interesting and give you more of an idea. This hopefully should give you somewhere to go with a summary of the data and some important questions and considerations to ask. Now, populations of people that could be at risk for an adverse effect. So these are the people, this is a small population of people who will not respond well to the vaccine. It's going to be heightened if you have an autoimmune issue. Actually, people can actually get autoimmune diseases after being vaccinated. Now, it's a very small percent. 0.01% of vaccinations worldwide result in an autoantibody response where people get autoimmune issues from a vaccine. 0.01% is a very small relative amount. However, it's not a small absolute amount when you talk about millions, hundreds, probably hundreds of millions of people. Who knows? We have nearly 8 billion people on the planet. There's going to be likely tens of thousands of people who have adverse effects, some of them, or hundreds of thousands of people, millions of people maybe, who have adverse effects, some of them with autoantibody responses. Be on the lookout for that, because the media, people will run with those things and could make them out to be like they're bigger than they are. But it's an important consideration. If you are immunocompromised, you've had previous poor responses to previous vaccines, if you have, that's especially, you should be more cautious and considerate, and your risk profile is different. And people that are allergic to any compound found in the vaccine. So it's important to ask, what are the compounds within the vaccine? I don't have those answers. I have not read those answers. I have not found them yet. But if you are going to get it, you do have allergic reactions or a history of autoimmune issues, allergic reactions, that may be an important question for you to ask. So, all in all, so far, this is not a black and white conversation. There is nuance and gray area. Everybody will have their own answer depending on their personal health, age, demographic, and location. Morally, ethically, it doesn't seem intelligent or reasonable to judge everybody the same way in whether they should or should not get any vaccine or put anything in their body. Doesn't matter about a vaccine. Any substance can have an adverse reaction. It is up to each individual to be well informed, critically think, and ask honest, objective questions, do their best to remain unbiased, and look at the birth of evidence, wide birth of evidence, such as what I was attempting to dissect and summarize here, and make a risk assessment based on that at this current point in time, because it may change. Your state may go from 10,000 cases a day to 100, and then 5, and then 0, whatever. That's going to change your risk. I hope this was valuable. I feel obliged and obligated to do things like this because in a world of sound bites, people who claim they have short attention spans and people will claim the world has a short attention span, I will fight against that with detailed, open, comprehensive discussions to get people honestly discussing information in the most objective, unbiased way so we can all find our way to create the best, safest well-being and livelihoods for each other and get along on this planet a little bit better. I hope it was valuable.